Okay, so thanks for coming. Sorry for misleading you with the calendar invite. Uh, I had like a clash within my invite list. So thank that you can make it. I suppose the others are still coming. So in the meantime, we just continue with what we've done previously and start with the new stuff for today. Can everyone see my screen? You can post it in the chat if you cannot see it, or you can say yes, 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 you can. Okay, okay. Tammy can to see. Give me a signal. Can you to see? It's, I believe you can see it as well. Okay, so we will start today with a recap of what we did last week. No, not last week. What we did yesterday. And yesterday we talked about functions and how functions work, and when you use them, what are the best practices for using functions in Python. And we'll do a recap. We also talked about global variables, like variable scopes, and when you how to use local variable, how to use global variables. So today it's gonna be about understanding how Lambda expression works. Also, I would just cover what we did yesterday just for the first 5 to 10 minutes. And so at the end of the day, you should be able to understand how to use Lambda expression in Python. So a quick recap of what we did yesterday. We talked about variable scopes, and we said uh, we call scopes or variable scopes as which part of the program a variable can be referenced from or used from. And an example, we had various examples yesterday. I will do a quick one today. Today we are not going to be using the browser, so we are going to be using, just give me a second, desktop. I think I have something on my desktop. Just give me. Okay, so desktop. Yes. I'm just looking for the file. We have something called the Python. Yep. Python. Yes, so we can open it. I will just open it. It's taking time to load. You should see it very soon. Can everyone see my? If it's too dark or you cannot see anything at all, just please let me know. I can change it to white if it's not readable. The font is too small. Okay. I think it's too big now. Over now? Are we using Jupyter? You can use Jupyter as well. Yes, you can. The other one is better. Which other one? The bigger font, like this one? Okay. Alright, so in that case I will close this bar because we do not need it for now. So we were talking about we can use either Jupyter or we can use the VS Code. Here I'm using VS Code. For the sake of everyone, I could just use Jupyter instead. I'll just use anacondas. I'll just kill this one, so I will use Jupyter. So anacondas is taking time to run. So while it's running, I will just keep talking. So variable scopes, it refers to where the variable are being referenced in the program. So we have different kind of variables. We have different kind of scope. So we have the global scope and the local scope. So if you, oh, there we go. So I'm just gonna launch Jupyter. I could minimize this. Then we're gonna get a browser. So there we go. There. All right, desktop. We can open this one. I will just create a new one. Yeah, we have a new one, fresh one for today. So I'm gonna call this Lambda expression. I know the font is a little bit too small, so I will increase it now. Please let me know if it's within what you can see. Cool. Cool. Okay, great. So we go back to variable scope. So I said we have global scope and the local scope, and I said variables that are declared at the top of the program, we call them global scope because we can access them from every other part of the program. And the local scope variable are those variables that we declare inside our functions, and they cannot be accessible from outside. And a quick recap of that is we're just going to write a small function here. We call it do something. That's going to be the name of the function. We're just going to return let me use the double quotation because I prefer to use the double quotation. I'm just going to return I am doing something. And I said in terms of functions, if you do not return it, if you don't return a function, you actually are not returning the variable. So in this case, we're returning it so we get the variable. And what I want to do here to make it more sensible is, all right, let's do it this way. So I'm just gonna cut it off. I will give it another name, which is let's call it let's do. So I'll give it the string call I'm doing. So then I will return let's do here. Let's do. Yep. Some. Let me remove this. That's another language. So we have let's do, which is this, and it has a string of I am doing something, and we are returning it here. And in order to call the function, we'll just call do something, and this is how we call the function basically. So here there's something to make it more more sensible. I will change this to I am local scope. Local scope. Yeah. So imagine that I want to print let's do. So let's say print let's do. I won't be able to reach let's do here because let's do is local to the function do something. So it's not accessible from the outside. So here we say let's do is a variable that is scoped, local scoped to do something variable, do something function. And in order to have something global, I will have to define it outside the function. So here I could say let's call it let's do, so we can really stress that this is a global scope. So we call it I am global scope. So if I say print let's do here, it's gonna print let's do here, because this is a global, it's global scope. So let's do, I can access let's do inside the function do something. So if I say print, uh, in this case, oh yeah, it doesn't make sense, typo. So you see, here we have I am global scope. So this print let's do is here calling let's do. It's printing what's here. And for me to have access to what's here, you would I would have to call this function. And because I know that the function is returning let's do, and don't forget that because we are not printing the result or the values of the function, that's why we don't get anything when we call it. We are calling the function, but if you do not print the values inside the function, it's not going to actually return something that you can. It's not going to show something. It has something, but it's not showing it. So in this case, if I say print, so it's here, you see, it's printing the something which has let's do local variable to the function do something, which is local scoped, and the global scoped is let's do. And one thing I can do here is if I want to, like, I can also use let's do inside this function, because this is a local, it's a global variable, and like we said in the definition, a global variable, these are variables that are declared on top of the program and they are accessible within any function. Here, if I want to say, okay, let's do, but I want to add, I want to concatenate another, or I want to concatenate it to let's do, which the let's do here, I'm referring to this let's do here. So here, if I say it's reference before assignment. So here I will actually just do something like this. Do let's do two equals let's do. I will just say let's do two, and this should be fine. Errors should be gone. Let's do this first. It's reference before. Okay. In this. Sorry. No, you can tell me. You were saying something. Okay, so let's do it this way. So I'm not gonna put anything here. I'm just gonna remove this, and let's say let's do equals, I want to give it another variable name. Yeah, so here I'm saying name because I can reach let's do is global scope. I can call it within the function. So I'm assigning it. In the other error I was calling let's do. I was actually calling it before actually declaring it. So here it's name, I'm putting it inside a new variable, which is this Lincoln outside joined. I think it got disconnected. All right, so this variable here, which is, let's do its global scope. So I'm just reassigning it to the local scope here, which is name, then return name, and we have all this. So that's a recap of what we did yesterday, and one of the best practices you should learn to do is never declare too many global variables, because it's rare that you would have to do it, but you advise not to do it, because imagine that you're building an application for a bank and you have like 500 global variables. The issue there is might not remember how many variables you have declared. You might just lose track of everything, and so it's advisable to keep your scope to keep your variables local scope. So you just minimize the use of global variables, basically. Questions? Any questions? Signal? No. Okay, thank you. So I can move on. Today we're going to be talking about Lambda, and we're going to be talking about Lambda functions. And here, Lambda functions are actually small anonymous functions. Oh, okay. Sorry that you have network issues. Just I will. If you miss anything, I will send you the video after the call, or after the presentation. Yeah. Okay. So a lambda function is small anonymous function, which means it's more like a function you can easily use without actually like giving it a name. As it sounds, anonymous. It doesn't have a name. You just use it. It does what you need it to do without actually having to like give it a name. And it takes series of arguments, like it takes numbers of arguments, but it restricts you syntactically. So you have one expression with multiple arguments. And what do I mean by this? So I'm just going to show you examples very soon, but I need to tell you when you need to use it. So for instance, we have this function here. We have, let's use another function. We call it add. Declare another function, or add two numbers. So add two numbers takes in the first number and takes in the second number, and you just say return a plus b. Done. And so you just put stuff there. Well, you can actually do this without actually having to declare like a function saying add a plus b, and that's where a lambda function comes in. So how does lambda work? Now, for you to declare a lambda function, you always have to use the keyword lambda, and to the right hand side you have the argument here, and please do not forget we have the column here, and to the right hand side you have the expression. And as you can see in the code block below, or so you call the keyword lambda, and the argument I'm passing in here, it's x, and the expression here, it's x plus n. So let's do it here. We just take it away. So we actually want to say def is increase up. Yeah. Oh no. There we go. Why do I keep doing this? So I just want to have something like a function that just keeps increasing number every time. So I want to pass in n, and what I want to do is I just want to return. I want to do the addition internally inside the function, but I don't want to actually have to declare another name that's gonna undo the addition. I don't know if you understood what I mean here. So imagine that if I could easily say uh, inside the function increase, I could say def addition, then and take another something and say inside addition. I would just say since n is reachable here, I would say return n plus another thing, or maybe x. But with Lambda, all I need to do, since I want it to be anonymous, that's the point of having Lambda. I don't want to have having to give it a name. I would just say Lambda. Then, as it says, follow by the argument. The argument I want to pass in here is x, and the expression on the right hand side, so I want to say n plus x, n plus x, yeah. So here, that's it. That's all I needed to do. So this Lambda is an anonymous function that undoes the addition of n, which we pass in from the from increase function here, and we add x to it. Now the next question will be, what about if you say print is increase and you pass in, let's say, if you pass in number 4. I'm not gonna print it out, but I want you to guess what's gonna happen. Yes. Okay. Okay. So you say the okay. So 4 goes inside the function. Then your worry is that what exactly is x gonna do? Okay. So if we print this, you see what we get? It will print 4 plus x. Actually, it's a nice intuition, but no. This is what we get. So yeah, so this 0x, it's more like referencing the memory where it's been stored in the system, so we don't have to worry about it. And what we need to be really worried about or pay attention to, not worry about, but pay attention to is here it's telling us that this is a Lambda, that yes, you're actually parsing 4 inside function is increased, but I've got a Lambda there, and the Lambda is still missing. It's an anonymous function, but it's missing its own, you know, its own argument. So in order to use that Lambda, what do I need to do next? Anyone knows? Suggestions? Huh? I need to define. Okay, so you said I need to define the x. So how do I do that? You can tell me, I can type it, or you can paste it in the group. Mm, mm, okay. I'm gonna show you that. To the question Lakon asked, so the question again is, in order for me to, here we are getting that the lambda itself is being returned here, and what my question is, how do I pass the value to the lambda? You have any idea? If not, okay. So you're saying if I say uh, this is 3, okay, and I do what? Press enter. It should I press enter? Okay, okay. We are getting the same. We still yes. Question. Yeah. Yes. Lincoln is right. Yeah. No, 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 no. I'm just saying. I saw is. I'm not saying it's actually right in terms of the code. In terms of the way thinking about it, it's actually it's going in the right direction. Doesn't mean it's there yet. It's on its way. Yeah. So yes, let me go there. Mm-hmm. Uh, mm, mm. Okay. Yes, I can. Mm, mm. Lambda. Yeah. Okay, that's you're absolutely right about that. The so okay, you're saying I should take it up here. All right, we're still gonna get the same thing. Okay, so nice intuition, guys, and we'll show you how it actually works. The way you're thinking about it is right, but here is how it actually works. So I'm just gonna break it down. The function is increase takes in n, and here we already passed in 4, and that 4 belongs to it belongs to n here, which is this one. So this x is missing. So now, in order for me to use it, I could say, let's call it y equals is increase, yeah. So I would, since y is increased and I pass in 4, because what I'm basically doing now is I'm passing the result of this into y, and for me to get what the actual result of the lambda, I would say y, then I need to send in the values for x, and in this case, since we are just adding them together, let's just send 1. Exactly. So it's like it's an anonymous function, but you want it to do a trick. So it's like a function inside a function. So here is the first function. Lambda itself, like we said, is an anonymous function. Yeah, I was just using it to demonstrate. Okay, so that's how Lambda how it works. So we can go. Yes. Yeah. That's it was right in front of you guys. I was like, yeah, I did it on purpose because there too. Yeah. Okay. So Lakon is asking, why can't I define x just like I defined n? Okay. It's a great question. The thing is, you because of the way Lambda itself works, I could say, well, if you want to define x, you can say why can't I define x just like I define n? You understand? Can I continue? Yes, I can. Okay, so I just want to stress something here. So I want to go back to Laken's question, which is why he's asking define x and defining x the way n was defined. Here, if I actually want to do that, I would say, well, x, oh, no, not capital, is this, like if, again, argument, expression. So then under it, uh, I would say z is 1. If I say z is 1, I could just say c equals to z. And here I already have the value for that lambda. So if I say inside this lambda, I just copy it here. I can paste it under here. Let's just take away this one. Take away uh, 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 okay, let's just use the print. Print 4. So here I will just say uh, instead of x, I need to pass in the variable. We have in x, we have n already inside. Okay. So x will be okay. Let me just print this first to see what we have and see. So this one I will comment it out. The shortcut doesn't work. Jeez. Let me just copy this code. So if I say print C, it will print it. Then I can reuse C inside that function. So if I want to reuse C, I wouldn't have to use lambda anymore. So I would just remove the lambda. So I would say n plus C. Then I just print the result of increase. Do you understand? Does it make sense? Questions? Making sense? Okay, how is the previous code works? Imagine you have x equals to 4. So here, you say if x equals to 4, this, is this what you mean? Okay, it won't work because the thing is, because of the way Lambda works, it's not going to take in, because of the x is just something, this x here has nothing to do with what's here. Unless you pass these x here into this one, because remember, this is a lambda function, and a variable x becomes the lambda function x, and here I'm saying c equals to z, which is this lambda function we have here. In order for this 4 to go inside this lambda, I have to say z, then I send it the x, then if I print it, the 4 would work. Does it make sense? Still have doubts, guys? Questions? Uh, okay, so now we go to the next one. It's another example. Here I'm just saying, demonstrating another way. You can use Lambda to like sort a list of a tuple, because here we have tuple. You can use it to sort a list of tuple, and here I'm literally calling I'm here calling the function Lambda. Then I'm saying when it's sorting this list, it should use it should use index 1, and index 1 here, which means because sort itself goes through this list, and when I say index 1, I'm talking about instead of it using the position and the index 0 to sort it, it's going to use the names to sort it, because this is index 1. And so this is how you can use Lambda to do some computation. You can use it to do almost anything you want, as long as you know that you just need that function for a short period of time. Because here, if I probably want to do sorted, I don't have to write, okay, def equals the name of the function, then I need to call the function, then I need to pass an argument here. With Lambda, I already did it. And in fact, this is an anonymous function. It doesn't have a name, but it does what I want it to do. Doubts? Mm. Yeah, yeah. The default sorting will be, yeah. Yes, it will. Mm. You mean how would it obey the lander team equals team with index 1 at the print to the team itself? Because it's a lambda function, you don't actually need to reference it, because here I'm just inserting the lambda function into the key, and the key just takes it in and do some computation and rearrange the. Yes, yes, the sorted. Uh, okay, it's new or the code knows that it's supposed to print the sorted version because Python read from top to bottom. So it's mm, yeah, exactly. But we can actually just uh, give it a spin. So we can say uh, the Python. Okay, I think I still have it. We just. I think it's Python visualizer. So we have 3 minutes. Okay. Okay, we can just let's. I can just define. Let's do it this way. Menu. So I just copy this. So this is okay. We just switch this to 2. This we give it let's give it city because it's pretty short. I give it 3. I give this all because it's short as well. I give it this one. I can give it. I'm not a fan of the club, but so here I'm saying teams dot yes, and I'm saying key equals Lander. Then I'm passing in again as we start from the right the argument, and on the left the argument, on the right. Yes, yes. Okay, and we can say team. You pass in 1. Then just print team. Uh, this. Yeah. So we have 1 minute. Yes, questions, please. You have questions? Because, yeah, we are starting with this because remember, yeah, this is a tuple, and yeah, yeah, sure. That's exactly what it's sorting according to the exactly. Have I clarified yours? No? Yes? Mm, mm. In this case, you could. Hmm. In that case, I need to check how sorting works. Yeah, I know that you could easily just pass in. Um, yes. Okay. So we you're gonna get out of key. It's gonna say out of index because what you're saying is tuple out of range, and yeah. So you're gonna run out of the index. For instance, if I put back 0, I get the same thing back. And if I remove it, I still get, yeah, okay. So you just keep testing, trying stuff. All right, so we are, yes, really? From yesterday? Well, I put it in the Slack channel, it's there. Yeah, I will, I step to do that. I prefer the Slack channel there because we can easily just ask questions and just do stuff. So, best practice, use Lambda functions when an anonymous function is required for a short period of time. So if you just want to do some trick, you don't want to define extra stuff, you just plug it in there and it just does it. Because imagine here you want to define a function uh, that's going to do this. And with this has been done for you. So we have questions, we have exercise. I know that time is far spent. We are 3 minutes way late. What I can do is I can solve the first one. I can quickly solve the first one, which I have done, though I will show you the code. I have solved the second one as well. So the first one is these that I did here. I'm saying, right, create a lambda function that takes one parameter and returns it, which is this. So this lambda function takes an x and gives me back x. And here, I'm basically just putting 4, which is this x, I'm putting, yes, and I'm printing it out, so it gives me 4. So if I parse in 5, I should get my 5 back. If I parse in 6, I get my stuff back. So the second one is create a Python program to sort a list of tuples using, yes. Yep, so on the questions, let me see. Yes, it will change because in the function is increase, it's using the value of c, and if I change, it's defined here. Okay, so I solved that, and the second one, which is create a Python program to sort a list of tuples using Lambda. So here we have it, a list, which is the list, and have tuples inside them. And the third one is to write a program to sort a list of dictionaries using Lambda. So these, I will let you guys figure it out. You can try the rest as well. We have write a Python program to square and cube every number inside a given list of integer using Lambda. And I know this will be a little bit tricky, this one. Write a Python program to create a Fibonacci series up to n using Lambda. And the last one is write a program to find the palindrome in a given list of string using Lambda. So tomorrow at same time 8 p.m. I would expect everyone to have their solutions ready. Yes. So I will send this piece of code in the Slack channel, so you can always refer to it and just try it. Okay. Questions, doubts? Later I'm gonna send you the slides as well. Yes. Last question. Yeah. Sorry. Yeah. Yes. And so it's like I'm telling it how it should go about orchestrating the sorting. Yes. Yep. I'm just. Yes. I'm sending it to you, and you have it there. I just sent you a link. Yep. So I guess thank you very much, guys, and I hope you have a lovely evening and happy coding. And please try to go through what we've done today, because tomorrow we're gonna go into we're gonna start new content. So we'll be talking about classes, and we should talk about dictionaries a little bit, because I feel that I didn't stress how dictionary work. I could just put a little bit of light on it. So please let's give it a go. And you can probably use Lambda for the project, or maybe look at your project again if you're feeling challenged, like, oh, I could make something a little bit more fancy, more Pythonistic, like, yeah. Let's see. So until tomorrow. Yeah. Okay. So enjoy your evening. Enjoy the rest of the day. I will send a video on their Slack channel so you can uh, go through it again. Yeah. So see you guys tomorrow. Yeah. Bye. Thank you. Yeah. Okay.